Okay, example 3 here wants us to do a reflection on the coordinate plane. So it tells us here we have quadrilateral F, G, H, J, and then it gives us the coordinates for F, G, H, and J. And then it says for part A, graph and label F, G, H, J, and reflect it over the x-axis, and then come up with a general rule for reflecting over the x-axis. So let's first graph our quadrilateral FGHJ. So F is going to be 0, 3. So here is point F. Okay. G is 2, 4. So here's the point 2, 4. That's going to be point G. H is 4, 2. So that's going to be right here. Here's point H. And then J is negative 2, 0. So we go negative 2, 0. Here's going to be point J. And then if we connect our points on our quadrilateral, there is our quadrilateral FGHJ. We want to reflect across the x-axis, so that's our horizontal axis here. So we want to reflect over this line here, the x-axis, also known as y equals 0. Right, the x-axis is also known as the line y equals 0. So we want to reflect over. And again, if you imagine what we did in the last example with the piece of paper, if you fold the points over, we're going to figure out where they end up on the other side. So if we start with F, our first one, F is at 0, 3. Okay, so it's 3 units above our line of reflection. So if we fold this down like a piece of paper, it's going to end up 3 units below. Right, F was 3 units above, so F prime is going to be 3 units below. Okay, G is 4 units above the line of reflection. So again, imagine folding it down. If it's 4 units above and you fold it down, it's going to end up 4 units below. So there's G prime. Okay, H is 2 units above the line of reflection. So if we fold it down, it's going to end up being 2 units below the line of reflection. Okay, J is on the line of reflection. So when you fold it over, it's just going to stay right there on the line. It's not going to move. So J prime is going to be in the same location as J because it's on that line of reflection. So again, if you fold the paper over, whatever is on that line is going to stay on that line. Okay, we can then connect our points. Okay, and we have our reflection. If we notice here, again, it's a rigid transformation because the angles are all the same and the lengths of the sides are all going to be the same. We're just simply reflecting it over that line. Okay, it then asks us to write a general rule. So to write the rule, let's first look at some of the coordinates here. So F was 0, 3 was the coordinates for F. If we look at the coordinates for F prime, those coordinates are going to be 0, negative 3. Okay, if we look at the coordinates for G, was 2, 4, G prime is going to be 2, negative 4. Okay, if we look at H, H was 4, 2, H prime is going to be 4, negative 2. And if we look at J here, J is negative 2, 0. So J prime then didn't change. It was still negative 2, 0. So what we notice in our pattern is we're going from 0, 3 to 0, negative 3, from 2, 4 to 2, negative 4, from 4, 2 to 4, negative 2, and from negative 2, 0 to just negative 2, 0. We notice that the sign is what's changing for our y values. So if we wanted to write a rule for reflection over the x-axis, it would be simply that xy, right? When you reflect, do a transformation where you reflect it over the x-axis. So R stands for reflection. The subscript there is x. So we're reflecting over the x-axis. The x value stays the same, right? 0 stayed 0, 2 stayed 2, 4 stayed 4, negative 2 stayed negative 2. But then we're changing the sign on the y value. So 3 became negative 3, 4 became negative 4, negative 2 became, positive 2 became negative 2. 0, right, which doesn't have a sign, right, is like negative 0, which is still going to be 0. So that would be your general rule here for reflecting over the x-axis. Okay. Right. If we look at, see if the next one's a try it, right, it's going to ask you to do the same sort of thing for the y-axis. So let's try that. Okay, so let me refresh the page, and that way the script will go away. Okay, and hopefully it will load. It loads really slow when I have the Screencastify running. Okay, but this one's going to end up being very similar. So we're going to plot the points, and it restarted the whole thing. Okay, let's go to... This just really is not the most well-made program in the world. For all the money the school paid for it. There we go. Okay, so this one's going to end up being very similar. Okay, so if we graph it, it's going to have the same original points. So if we put those in real quick, we got, let's do it in red. We got 0, 3, here's F. We have G, 2, 4. I didn't even graph it right because I'm trying to go fast now. So there's F. Here's G, 2, 4. And now it just shifted on me. I'm not really sure why. It's not frustrating at all. Okay, 2, 4 is going to be G. 4, 2 is going to be H. And then negative 2, 0 is going to be J. So there's our quadrilateral. Okay, this time we're reflecting across the y-axis. So if we look at our line of reflection, that's going to be our y-axis, also known as the line x equals 0. Okay, so now if we want to reflect over, again, it's just like folding this way, we're folding long way. So right here, if we start with F, F is on the y-axis, so it's going to stay there. So F prime is going to stay on the y-axis. Okay, G is 2 units to the right of the y-axis. So since we're 2 units to the right, if we reflect it over, it's going to end up being 2 units to the left. So G prime is going to be over here, 2 units to the left. Okay, H is 4 units to the right, so H prime is going to be 4 units to the left. Okay, and then J here is 2 units to the right, so we're going to go 2 units to the left. So J prime will be over here. Okay, and then you connect your points. Right, and there's your reflection. Right, if you fold it in half, all those points are going to line up on top of each other. Right, and if we wanted to write out our points here, so F prime, right, stayed at 0, 3. Okay, G prime ended up becoming negative 2, 4. Right, it was 2, 4, and then it became negative 2, 4. H prime was 4, 2. It's going to become negative 4, 2. And then J is negative 2, 0, so J prime became 2, 0. So unlike the x-axis, when we're reflecting over the x-axis, where the sign of the y value changes, when you reflect over the y-axis, the sign of the x value changes. So the rule we have here, right, is that xy right? When you reflect over the y-axis, so that's what this stands for. It's this, R stands for reflection, and then the y is the subscript. So we're reflecting over the y-axis. We're going to have to change the sign on the x value, and then the y value is going to stay the same. Right? And then that would be our general rule for reflecting across the y-axis. Okay, and then the last one here is your try it. So you want to reflect those points over the x-axis and the y-axis using those rules.